Welcome. Today we're tackling two fundamental concepts in chemistry, the octet rule and lattice energy. This might seem unrelated at first, but they're actually intimately connected, explaining why certain compounds form and how stable they are. We'll explore each concept individually, then see how they work together. The octet rule is simple yet powerful guideline. Atoms tend to gain, lose, or share electrons to achieve full outer shell of 8 electrons. Think of it like a full set of Lego bricks. It's much more stable than having a bunch of loose pieces. This stable configuration mimics the noble gases, which are famously unreactive because their outer shells are already complete. Let's look at sodium chloride. Sodium readily loses one electron to become Na positive, achieving a stable octet. Chlorine happily accepts that electron, becoming chlorine or Cl negative, also with a complete octet. The attraction between these oppositely charged ions forms an ionic bond.
Covalent bonding is different. Atom shares electrons to achieve octets. In methane, carbon shares its 4th electron with 4 hydrogen atoms, completing 8 octets, and each hydrogen gets it stable duet. It's important to remember that there are exceptions. Some atoms can have more or fewer than 8 electrons in their outer shell. We'll touch upon this later, but for now, let's focus on the common cases.
Now, let's talk about lattice energy. This is the energy released when gaseous ions come together to form a solid crystal lattice. Imagine it like the glue holding the ions together. The stronger the glue, the more stable the compound. The Born-Haber cycle is a way to calculate lattice energy, considering all the energy changes involved in forming the compound. It's a bit complex, but the key takeaway is that a higher lattice energy means a more stable compound. What affects lattice energy? Two main factors: the charge of the ions and their size. Higher charges mean stronger attraction, leading to higher lattice energy. Smaller ions can get closer together, increasing the attraction and lattice energy.
Now, let's connect the dots. The octet rule explains why ions form. Atoms want that stable octet. Lattice energy tells us how stable the resulting ionic compound is. A compound formed from ions that has successfully followed the octet rule will generally have a high lattice energy, making it a more stable structure. Let's look at a few examples to see the connection in action. We can compare the lattice energies of different ionic compounds and see how the charges and sizes of the ions correlate with stability.
So, the octet rule and lattice energy are two sides of the same coin. The octet rule explains the drive for stability, and lattice energy quantifies that stability in ionic compounds. Understanding both is key to understanding chemical bondings and the properties of matter.
Thank you for watching. This concludes our discussion on lattice energy and the octet rule. We hope you gain valuable insights into the world of ionic compounds and chemical bonding.